Thank you, Nick. You can have the point. We talked about completing the square, which you got to finish up today. What are we also going to talk about with completing the square? So we're going to talk about two things: quadratic formula, table 2 math form. Okay. We have something coming up on Monday. What's coming up on Monday? Yes, there is a math workshop test, so I'm going to use points to 2 and 5. But I'm also going to use the point to 4 because there is a quiz as well. There's a quiz on completing the square and the quadratic formula. I gave you, well, I didn't give you, you had the option yesterday to go ahead and pick up a checkpoint. If you didn't do that, that's part of class today is to get this checkpoint done, or to work on this checkpoint. Yes, the math workshop test is coming up. Completing the square and quadratic formula quiz on Monday. If you're not going to be here Monday and Tuesday, I am going to be nice and not type in the zeros until sometime like midweek after Thanksgiving. I'm not going to put in zeros for that over Thanksgiving. But you're going to have to make it up. Why? Obviously, you can't do quadratic equations and completing the square or the quadratic formula in advance because you hadn't even heard one of those yet. But if you were wanting to take the math workshop test in advance, you could definitely come like tomorrow during zero period if you were wanting to do so, because you're not going to be here Monday and Tuesday next week. Okay, let's go ahead and get rolling on these notes because there are a lot to do. If you don't pay attention, bless your heart, because I don't see how this can go off. Good grief. Okay. Were there any questions about the 3 I asked you to do yesterday? I asked you to do 3 of them. I said try 7, 9, and 11. Oh, if you think I'm not going to check to see that you tried 7 through 11 by the end of class either today or beginning of class tomorrow, you're wrong. Yes, dear. Oh. Yes. Did you have... You know I didn't do that. You know I did 25 over 4. Did you have x plus 1/2 squared equals 25 over 4? Huh? Okay, then on your top one, what did you decide to add to both sides? And but you're going to do the fraction, so it was 1/4. Okay, so on the second line, I have 25 over 4. And you have 6.25. And I have x plus 1/2 squared. You have x plus 0.5 squared. Okay, well then something's gone wrong after that. But you and I both know you're going to want to fix that anyway because you did decimals. And you know I'm not going to see any decimals. Yes, no, we're not doing any decimals at all with completing the square. We talked about math right. That's what we're going to press to make sure we got our life together. Okay, were there any other questions about 7, 9, or 11? You tried them and you're stuck on this. Okay, well then apparently you need more time. So good for you. If you got these done by the end of class, show me. It is going to be a homework grade. I'm going to check it probably tomorrow. I might not check it till Monday, but you know some of you aren't going to be here Monday. So the sooner you show me, the better. I am going to type in the zeros for this homework. Okay, we skipped 2 problems yesterday on the front page 21. Why did we skip those 2 problems? You know Jack said it best. Good point, Jack. Leading coefficients weren't 1. Okay, but overall we were following the same process over and over again. How are we completing the square? What are we doing to that middle term? Dividing it by 2 and then squaring. So middle divided by 2 squared. Middle divided by 2 squared. So let's look back over, for instance, number 1 from yesterday. Looking back over what we did. We had a 10 in the middle. 10 divided by 2 is 5. 5 squared is 25. Yes, it always ends up middle divided by 2. That's the number you put below. And then that number squared is the mystery number we add to both sides. So number 3, the middle was negative 8. Negative 8 divided by 2, negative 4. Negative 4 squared, positive 16. That was the mystery number we added to both sides. Now it got kind of annoying when we got to number 2 because of that 13. What's wrong with the 13? It's odd, 2 and 5. It is odd. So when we divide by 2, negative 13 divided by 2, we can't reduce that. But then that squared was 169 over 4. But that still ended up being nice because we still had perfect squares. 169, 4, 25, those are all perfect squares. And there is a reason that keeps happening, and it should keep happening. I mean, there are times it won't happen. Don't freak out if it doesn't. But it should happen pretty often. Okay. If you're questioning yourself, so like on number 2, we got 9 and 4. If you're really wondering if those are the answers, what could you do to find out? You could plug them back in. Then you can have a point for that. I'm looking for graph it, so you can have a point. If you graphed it, your graph on your graph of this quadratic function, x squared minus 13x plus 36, better cross at 4 and 9. You can always check your answers by graphing. Okay, and then probably the hardest question of the day. On number 6, we got answers that involved the square root of -1, so we used I, so we had imaginary answers. What does this mean about the graph of this function? 2 and 4 get a point. It doesn't even cross at all. In fact, if we graph number 6, I think it looks something like this. It never even crosses that x-axis. So again, if I have an answer where I start using imaginary numbers, I might want to graph it and make sure my graph never crosses the x. It better not. If it does, you've done something wrong. Okay, let's go to number 4, and then we'll do 5. And I'm hoping to talk about completing the square and the quadratic formula today, but that didn't happen first period, but you normally all are a little more on it. I guess a little more awake by now. Number 4, remind me again, what's bothering us about number 4?
2 in front of the x squared.
The 2 in front of the x squared. Okay, so let's get rid of the 2. Let's divide every single thing by the 2. If we got rid of the 2, we would just have x squared. Now, is it annoying that we now have 7 over 2x plus 5 over 2 equals 0? Well, yeah. But we got rid of the 2. It's now a 1 in front. So literally, that's what we're going to do. When the leading coefficient is not a 1, divide by that leading coefficient. So now it is a 1. Now, is it terribly annoying that we have fraction land already? Oh, yeah. But we can handle it. So on the left side, I'm going to leave x squared minus 7 over 2x. And I'm still looking for this mystery number. It's going to equal negative 5 over 2 plus the mystery number. I move that 5 over 2 to the right-hand side. And then I add in my little squiggle space for my mystery number. Okay, we've been doing middle divided by 2 and then squaring it. We're still going to do that. What is our middle term this time? It is negative 7 over 2. So on my calculator, let me zoom out a little more. On my calculator, I'm going to do negative 7 divided by 2. That's my middle. I went ahead and pressed enter. I still haven't done the divided by 2 or the squaring. I just went ahead and pressed enter. Divided by 2. But this is decimals. I don't want decimals. No fractions. Math frac. So I did middle divided by 2, and I've still got to square it. And I get 49 over 16. So again, middle divided by 2, negative 7 divided by 2. So that's my middle. I divided by 2. I squared it. And of course, I turned it into fractions at some point. Nobody wants the decimals except Gilberto, and he doesn't actually want them. He lied. He wants the fraction. So middle divided by 2 squared, I actually got 49 over 16 to add to both sides. Are there any questions about how I got, let me zoom in on that because I see Nick's went on. Any questions about how I got that 49 over 16? Even though it was annoying, I still did middle divided by 2 and squared it. It just stinks because the middle was already a fraction. So you had to do negative 7 divided by 2, divide it by 2, and then square it. Okay, well, when I did negative 7 divided by 2, when I took that middle and I divided by 2, and I turned my answer into a fraction, I got negative 7 over 4. So seriously, if you'll take the middle, divide by 2, that's the number you put on the next line. And then when you square it, that's the mystery number we're looking for that we're adding to both sides. So just middle divided by 2 gives you the missing number on the next line. And then squaring it gives you that mystery number we're adding to both sides. And if you understood till here, I swear you've done all the hard work. Because from here on out, we're really going to rely on our calculator. Because while I don't mind changing -5/2 to have a denominator of 16. I don't mind. But I don't have to because my calculator can do it for me. So either, I don't know what's on your screen at this moment. If you have -7/4 on your screen, you squared it. So I have 49/16 currently on my screen. Like it's there. So my calculator last remembers that. So I can say plus a -5/2. And then, I can tell it, now I really want that as a fraction. So I'm supposed to get 9/16 on the right-hand side. Or let's say you really just wanted to type both of these in at the same time. You wanted to type -5/2 plus 49/16. I know we've talked about in the past, get on my calculation thing. I know we've talked about in the past that there is that alpha y equals, and you can press n/d and do 49/16 that way. I'm not saying that's a bad idea. I'm just saying that slows you down. So instead, what I do is I just use a lot of parentheses. So -5 divided by 2, I put that fraction in parentheses. Plus 49/16, I put that fraction in parentheses. And literally, when I put fractions in my calculator, I get lazy at this point on in math class. Like algebra 2, trig, pre-cal, cal. Anytime I put in a fraction, I just put my fraction in parentheses. Okay, well, I pressed it, and you're like, but, Miss Compton, you said you only wanted a fraction. Well, yeah, I can still math frac. It still will give me the fraction. So I'm adding 9/16 on that right-hand side. Because -5/2 plus 49/16 is 9/16. But Jax likes fractions. So if he wants to, find the common denominator and keep going, he's still going to get the same answer as me. I'm just trying to make my life easier and rely on the calculator. You have to rely on that calculator? Absolutely not. Okay, so we added these two things together. We got 9/16. Which sounded great. Especially because 9 and 16 are both perfect squares. So we're here. And the rest of it should be easy from here on out. We've got to get x by itself, so we take the square root of both sides. We have x minus 7/4 equals plus or minus what over what? Thank you, Roberto, 3/4. So I really have x equals, ignore that problem below, 7/4 plus or minus 3/4. So now Gilberto has a life choice. He can either in his calculator type in 7/4 plus 3/4 and get an answer. Or he can just go ahead and add it together like Karen did. It's 10/4 and that reduces to 5/2. So she already knows one of the answers. But if you struggle with fractions, your calculator can handle it. So we did the positive. We did 7/4 plus 3/4. We still got to do the negative. 7/4 minus 3/4. Which is 4/4, which is just 1. But again, if you're questioning all your sanity because you're like, there were a lot of steps involved in that. I don't know that I necessarily did all those correctly. You can always graph the original in your calculator and make sure your graph actually crosses that x-intercept at 5/2 and 1 to make sure you're not crazy. No one has ever taken the graphing calculator away from you. Okay, are there any questions about number 4? It is a royal pain in the butt, and I label it as a hard, all because that leading coefficient makes us start off with fractions, and we have to be very careful in fraction land the entire time. Yes, ma'am.
Could you send Beth Gatelin to main office, please?
Yes, ma'am.
Thank you.
Okay, so let's go to number 5. What am I going to divide everybody by on number 5? And you know, if it were a 10, if the 10 was a 9 and the 8 was a 6, maybe life would be nice and reduced. But darn it, Jack should have a point, by the way. Once I divide by 3, a lot of this doesn't work out nicely. So I have x squared plus 10 over 3x minus 8 over 3 equals 0. What's my next step? Nick, get a point. So I have x squared plus 10 over 3x plus some mystery number equals 8/3 plus some other mystery number. This mystery number we're going to figure out because we are trying to complete the square. Okay, how do I figure out what the mystery number is? Okay, so what is my middle? Which really stinks. So I'm taking 10 divided by 3, dividing by 2. I'm going to go ahead and turn that into a fraction. And so I know on the second line down, I should put 5/3. Middle divided by 2, I did that. I've still got to square it. And it's 25 over 9. Now, if you want to do it all at once, so 10 divided by 3, divided by 2, squared, turn that into a fraction, you're still going to get 25 over 9. It doesn't really matter when you decide to press the math frac button. As long as you've divided by 2 and squared it, and at some point said fraction, it should still give you 25 over 9. And again, notice 25 over 9, pretty perfect squares. 25 is 5 squared, 9 is 3 squared. I swear I can talk math today. Whew. So I'm adding 25 over 9 on both sides. What number should I put on this right-hand side once I've added 8/3 and 25 over 9? When I've added those two, what's my next number? Yes. Okay, so I took my 25 over 9. I said plus 8/3. And then it said 5.444. And finally, Gilberto's on the same page as me. He doesn't want 5.444. He wants the fraction. He pressed frac. He got 49 over 9. Or if you want to do it all in one step, 8/3 plus 25. You can have a point for that, Gilberto. Divided by 9. So you can type in both at the same time. Get the decimal. I don't want the decimal. Math frac. I still get 49 over 9. So regardless, on that right side, I've got 49 divided by 9. Okay, but I want to solve for x, so what do I do next? Two and 5 get a point, so I take the square root of both sides. I've got x plus 5/3 equals plus or minus what over what? Can I get another point? I subtract 5/3, I've got negative 5/3 plus or minus 7 over 3. I'll give any group a point to tell me one of the two answers. So keep going. Gilberto, did you say that? Ellie and Gilberto said that, and you can earn a point for it. Negative 5 plus 7 over 3, when we added them, we did get 2/3. When we subtracted them, you got, yes, you can have another point. We got negative 12 over 3, which is negative 4. But again, if fractions are not your thing, and you're afraid you're going to mess up here on the last two steps, have no fear. While your calculator doesn't have a plus or minus button, you could do negative 5/3 plus 7/3 in your calculator. Negative 5/3 minus 7/3 in your calculator. And your calculator is still going to reach these two answers. It's really up to you. Are there any questions about this? Okay, well then let's flip to the page that was yours, the back side. I'm going to tell you the answers to 8 and 10, because now you can handle them. If we're still labeling easy, medium, hard, those are both hards. anytime I see a leading coefficient not 1 and they ask me to complete the square, it's hard because I've got to keep up with these fractions the whole freaking time. It's terribly annoying. Okay. The answer to number 8. You've got two choices. You can either leave it as x equals 3 plus or minus square root of 33 over 4. So you like to do a giant fraction answer. Or you can do two tiny fractions. 3 over 4 plus or minus square root of 33 over 4. It is up to you. Either one is great. Giant fraction, two tiny fractions. Personal preference. And again, it's a hard. Number 10, also a hard. Our options are x equals, if you want a giant fraction, 2 plus or minus the square root of 10 over 3. If you want two tiny fractions, x equals 2/3 plus or minus the square root of 10 over 3. It is up to you. Are there any questions about this? Okay. So when I get done rambling, because I'm going to keep rambling because we've got time. When I get done rambling, you have these 5 problems that you want to finish. And you still have the 3 problems from your checkpoint you want to finish. But since we have a lot of time left, let's see, it's only 9:34, and you don't leave till 9:58, we have some time to talk about the quadratic formula. So let's go ahead and talk about it a little bit. But for the love, don't forget about completing the square. Okay, I want to go to page 24 in your notes. If you did not like completing the square, well, it is an important part of algebra 2 with trig, and you must be able to do it for our next assessment. Like I told you yesterday, when I get to choose in life how I'm solving any kind of quadratic, I don't factor, I don't complete the square, I don't even necessarily graph, well, I should always graph it, but I don't even necessarily go to graphing first. My first go-to thing every single time is the quadratic formula. The hardest part about the quadratic formula is actually taking the time to memorize the quadratic formula, which is why at this time I will pause and sing you my song. Because no, YouTube does not need the formula at the top. Your goal tomorrow would be, you had to use it. Well, I think you learned it in Algebra 1. I know in geometry we used it, but I'm a sucker and I put it on the board the day of the test. I'm not a sucker in Algebra 2 trig. You gotta know it. Okay, so again, it's, I'm not singing this time, negative b plus or minus the square root b squared minus 4ac over 2a. So to find our two answers, we're literally going to plug every piece into this formula. Where do the a, b, and c come from? What form? 40 point. Let's try and go for it. So literally, if your answer is not in, if your problem's not in standard form, first thing to do is put it in standard form. For instance, on number 6, what's a? What's a? What's b? What's c? Okay, every group can have a point. Literally, I'm just going to plug this into that formula, and I'm going to get out the two answers, meaning the two spots where my graph crosses the x-axis. I'm going to know just by plugging and chugging. Okay, we talked about there were 3 types of graphs. Tell me about the 3 types of graphs of quadratic with the x-intercepts. How many times could it cross? It can cross once, twice, not at all. Okay, so it could cross twice. It could cross just once. Or it could cross none at all. And when it crosses none at all, what kind of thing should we be looking for? Okay, so we already know this is going to be imaginary numbers. Okay, when we see imaginary numbers, why do we use imaginary numbers? What are they replacing? What's going wrong? Square roots, be more specific. So negative numbers under the square root. So if there's a negative number under the square root, that's when we would use it. Okay, well there's this part of the quadratic formula. So let's go. So again, here's the formula. There's a specific part of this formula that's super important. Any guesses as to which part is the most important in this weird looking formula? No, what? So, and I know you're just guessing, and I totally understand. Let me explain. The most important part is the part under the radical. Yeah, you said. Now, the reason that's the most important part is because if you get a negative, it's going to be an imaginary number answer, which means your graph didn't cross at all. If the part under the radical ends up being just 0, well, I'm not going to have a plus or minus there, am I? I'm just going to have negative b over 2a. That whole radical thing goes away. So if I only have one answer, that means that radical is a 0. And then basically, if your square root is any other kind of number, that's when you're in this case of I have 2 answers. So seriously, that's why the first set of the directions say find the value of the discriminant, meaning is your square root going to be positive, in which case it has 2 answers. Is your square root 0? If so, it's only got 1 answer. Is your square root a negative number? We're still in this imaginary land. So the discriminant is the part that's b squared minus 4ac. And literally from it, we know about the roots. Okay, again, if we got a 0, it has 1 root. If we got a positive number, it's got 2 roots. If we end up using I, it's got no roots. So that discriminant tells us a lot about how many roots. And then, of course, we could just actually plug it in the whole formula and get our actual answers and see did our graph actually cross the 2 spots we thought. Okay, so we're going to try a couple of these. But seriously, the easiest thing to do first is to check the discriminant. So we're going to check the discriminant. So A said find the value of the discriminant, so we're going to do the discriminant first. The discriminant, again, is the part underneath that radical, so it's b squared minus 4ac. So for us, on problem number 6, b squared would be 4 squared minus 4, a is negative 5, c is 1. So I've got 16 plus 20, which is 36. So what does that tell us about our answers? It's going to have 2 real roots. Now, again, have I actually, you can't see what I wrote? Now, have I actually taken the time to find those 2 real roots yet? No. But literally, just by checking the part in the square root, I already know what kind of answer I should get. So part C is us actually using that formula. So it was negative b, and you don't have to write it every time. I'm literally just writing it to help people. I don't care if you just straight up plug it in every time. Okay, well, negative b is going to be negative 4 plus or minus the square root. We already did b squared minus 4ac. The b squared minus 4ac, we already calculated that. It's 36. So I know it's a 36 under the radical. And then over 2a, so 2 over negative 5, which is negative 10. So I've got x equals negative 4 plus or minus 6 over negative 10. So I'm going to do negative 4 plus 6 over 10, negative 10. And I'm going to do negative 4 minus 6 over negative 10. And again, if you wanted to ask your calculator to do all of this, it can. I don't mind actually doing it and getting negative 2/10 is negative 1/5. But again, if Tylen would rather just type that in her calculator and press frac, our calculator can handle this. So I get 1 and negative 1/5. But again, if you're mad at calculating this by hand, you can literally type negative 4 plus 6, enter, divided by negative 10, enter, math frac, enter. It'll give you the same answer. Okay, so let's make sure we're not crazy. Let's graph this guy on the calculator. So I want to graph negative 5x squared plus 4x plus 1, which is our problem number 6. I'm going to graph it on my calculator and actually look at its graph. Lo and behold, it did cross twice. We're not crazy. It looks like it crossed at 1. It looked like it crossed a little before negative 1, so, but I can still second calculate. Make sure I've got those zeros right. Yep, negative 0.2 is the same thing as negative 1.5. But you can see, yes, Jerry, whatever you're wanting to do, I'm going to say yes to you, know that. Okay. It is negative 1.5. But you can see now why I really don't want decimals, because if you give me decimals, I don't know if Ryan's actually persevering with the quadratic formula, or if Ryan's still using our old calculator tricks. Okay, but if I want to calculate the second zero, I can still set my left bound, my right bound, make a guess. Yep, it's still at 1. So seriously, the 2 zeros are there. Any questions about that? We'll do 2 more and we'll call it a day. Let's do number 7. We're going to look first at the discriminant. It's b squared minus 4ac. So for us, what's b squared? 21 or 121, 22 or 1?
22.
Okay, so 22 squared minus 4, what's a? And what's c? Okay, everyone's going to have a point. And then actually calculate this and tell me what you get. 242. You did 20. 22 squared is 484, yes. But what's negative 4 times 1 times 121? What did you get for that? Okay, so we've got 484 minus 484, which is 0. So what does that tell us about our graph? Yes, everyone can have a point. Nick said it first, but he'll allow everyone to have a point. It's got 1 real root. Seriously, I'm not even putting in the formula. I've just checked the b squared minus 4ac, and I know it has 1 real root because my discriminant is 0. I'm telling you, quadratic formula is my BFF. So you're like, Miss Compton, you're crazy. Well, let's go ahead and graph this one. So it's x squared plus 22x plus 121. It doesn't show it on the screen well when you zoom standard, so I'm going to have to zoom fit. Look, when I graphed it, you can't actually see what's going on, so I've got to zoom fit or something. Maybe I'll just zoom out. Yep, it crosses once. So, seriously, the discriminant told us a lot about it. Okay, now let's finish it out and actually use our formula. So it's negative b, x equals negative b plus or minus square root b squared minus 4ac over 2a. So I'm going to have x equals negative b is negative 22 plus or minus square root. We've already done the b squared minus 4ac. B squared minus 4ac was when we calculated the discriminant. So we already know this is 0. And then over 2a, so over 2 times 1, I get negative 22 over 2, which is negative 11. So my graph crosses once, and it's at negative 11. And if I'm questioning myself and my sanity, I can second calculate my zeros, little to the left, little to the right, lo and behold, my 0 is at negative 11. I don't know why people don't like quadrant formula. Like I said, it's my BFF. Okay, let's see. It's 9:48, so I do want to give you time. So we'll save 8 and 9 and the rest of them for tomorrow. But seriously, my BFFFF. So if you think I don't love the quadrant formula and you shouldn't learn that one, I'm not going to bring it up a lot, you're wrong. It's my favorite. It's probably my favorite thing we've done this year. It's just so reliable. Okay, you had 5.